Okay, now today we're looking at the graphs of polynomials, and we're just going to look in the form where we can change the power and also the number at the front. So change the number up here, the power, and the number at the front. We'll start off with the a value being 1 and the power being 1. So we've got our standard straight line, y equals x, where the x value is equal to the y value. So the points along there. So let's first look at adjusting the power. So we'll go make the power 2 and we get our basic parabola. So the y value is equal to the x value squared. So let's see, 4 squared 16, 5 squared 25, negative 3 squared 9, etc. Okay, let's go on to x cubed. And here we get a different shape graph, but the thing you'll note is it's still going from this bottom left to the top right, like our y equals x. Whereas our parabola came down like that and turned back up. We've got that U-shaped graph. Here we've got this shape going from bottom left to top right. And the x value is a cube of the x value. So 2 cubed is 8, 3 cubed is 27. So what happens when you go to x to the power 4? You see we get a graph similar looking to the parabola, except it's not as pointy at the bottom, it's a lot flatter. But, 1 to any power is 1, so when you put 1 you get 1. The 2 to the power 4 is 16, so the graph gets very steep very quickly. The parabola sort of was going out like this, because remember when you put 4 in it was 16, so it was sort of going out along the lines like out there in comparison. So what would we predict if we had x to the power 5? Now we see that we can go back to the shape going from bottom left to top right, very similar to that cube one, but once again a lot steeper. But in between negative 1 and positive 1, it's a lot flatter than what x cubed was. I'll just go back to x cubed, and you can see that it's not as flat as that x to the power 5. So if we go to x to the power 6, if this pattern continues, we're expecting something in this U-shaped pattern. And look, x to the power 6, yes, we get that U-shaped graph, a lot flatter at the bottom though, and very, very steep. You can see when you put 2 in, it doesn't even record in this because 2 to the power 6 is 64. Then x to the power 7, we get that classic odd powered shaped graph. It starts from the bottom left and goes to the bottom right. Once again, it's getting very steep once it gets past 1 or negative 1, and very flat between the values of negative 1 and 1. So to the power 8, yes, again, we get that U-shaped graph, but almost vertical here. It's never vertical though. It's always going out as x goes across. The y value goes up, but the graph is always pointing out, even though it looks like it's almost straight, but very, very flat at the bottom. And x to the power 9, back to that shape, x to the power 10, x to the power 11, x to the power 12. So the conclusion we can make here, if we go right back, the odd powers have that slope. There's power 3, power 5, power 7, power 9, power 11. Now the even powers, let's start at 2, the parabola, u squared, then power 4, power 6, power 8, power 10. The family of the even powers are all that sort of U-shaped graph. Very flat at the bottom as the power gets very big and very steep as the power increases. So let's go back to our basic one there. So that sums up for us what happens when we change the power. So we can predict that the power causes the graph to be, if it's an odd power, it goes from this bottom left to right hand side. If it's a cube or more, it has that sort of shape. And if it's even power, it'll have that U shape. As the power gets bigger, it becomes very flat at the bottom. Alright, so what happens now when we change the value of A? So we'll first have a look at the cases where A is positive. So if we increase the power of A, make it get bigger, we can see it causes the graph to be dilated from this direction. You can see this x value here in the green dots match up, same x value, but this graph now, because the A value of 5, that graph points 5 times higher up. And you'll see that of all the matching points there. 2 becomes 210, and in this way minus 2 becomes minus 210, minus 4 becomes minus 420. So increasing the power of A, as we've already seen, makes the graph narrower. If we change the power, let's make it a parabola, and we've investigated this already this year, so we go back to a equals 1. We're going to increase the power of a, makes the parabola narrower and narrower. So we'll be predicting that we can determine the shape. The cube's going to have that bottom left to top right thing. As I increase the power of a, it's going to make the graph narrower and narrower. And you can see that's the effect it's having as I'm increasing a. And the y value is dilated, stretched by whatever the value of a is. So the y value here is 8, it's now 32. This y value here was 1, and now it's 4. So negative 1, negative 4, negative 8, negative 32. So it gets stretched. We go to a to the power 4, get that classic U shape. Let's go back to the case where a equals 1. And as I increase the power of a, it becomes narrower and narrower. Alright, and the same argument would be for any power that's jumped up to something like x to the power of 9. So it's got that classic odd shape, odd power shape graph. As I increase a, it's getting narrower and narrower. So we can say if a is positive, it makes, if a is bigger than 1, I should say, it makes the graph narrower and narrower. And the next thing we'll investigate is what happens if we make a negative. So I'll first go to negative 1. Now, the effect of making a negative 1, so here we're looking at the graph of y equals negative x. The red dotted graph is y equals positive x, positive 1x. And we actually say the graph has reflected in the x-axis. See, the original point here, 5, 5, now becomes 5, negative 5. 3, 3 becomes 3, negative 3. Negative 4, 4 becomes negative 4, negative 4. Alright, let's see what happens with our parabola, which we've already investigated in this year. And so we still get this reflection about the x-axis, that's like our mirror line, and it's flipped over the x-axis to get the new graph. If we go to the cube, so here the dotted line is our x to the power 3 graph. The black graph is negative x to the power 3. The bit that's down the bottom here has flipped up to there, and the bit that was over here on the right hand side flips there. So the odd powers, well, all the powers, they flip over the x-axis. There's x to the power 4, but negative x to the power 4, it's flipped over the x-axis. Noting that the point at the origin doesn't change. It's still 0, 0 because the point is on the mirror line, on the reflection line, it doesn't move. There's our power 6, power 7, power 8, power 9, power 10, etc. So the only other thing to investigate now is what happens if we make a more negative than negative 1. So let's make a negative 2 for the parabola, and we've met that before, it makes it narrower. If we make it negative 4, for instance, it makes it even narrower. It's still reflected though on the x-axis because of the negative. Makes that what we talked about, the hat-shaped one in parabolas. If we change the power to power 3, so let's go back to a equals negative 1, and got that reflection in the x-axis. The bit that was down here is now up the top, and the bit that was up the top is now down the bottom on that side. As I make a more negative, it still keeps it reflected because it's the negative, but it is narrower and narrower. Okay, so if I jump out to a power like negative up to the power 7 and make a more negative, you'll see the graph gets more narrower, and it's still reflected about this middle axis here, the x-axis. It's reflected about that. Right, just the only other thing we didn't talk about there is if the value of a is between 0 and 1, it doesn't matter if it's positive or negative, the negative causes the reflection. Here, it's hard to see that power there, but if we go back to our parabola, probably see it best, you can see having a number between 0 and 1 makes the graph wider. Now, if that's positive 0.5, it's still wider. So the negative only determines if it's upside down or not. With the go to a power like power 5, as I make a negative 0.5, you can see that it's actually been reflected, but it's actually gone out wider, quite a lot. But because of the big power. We see it more in the lower powers. Gravel's probably demonstrates that the best. Okay then, complete your worksheet and the graphs, and we'll pick up from there for the next lesson.